हेलो एवरीवन, हाउ आर यू ऑल? वेलकम टू एडिश्योर। आई एम डॉक्टर सुमन परमार। मैं आज आपसे बहुत इंपॉर्टेंट बात करने वाली हूँ। आप सबको पता है कि आईआईटी जैम और गेट का एग्जाम बहुत ही पास आने वाला है एंड बहुत ही कम दिन बचे हैं हमारे पास। अभी हम अपने इतने बड़े एक्सटेंसिव सिलेबस में क्या पढ़ें या क्या ना पढ़ें, क्या छोड़ें, क्या पिक करें, ये बहुत इंपॉर्टेंट क्वेश्चन हो जाता है। अगर हम मैथमेटिकल इकोनॉमिक्स की बात करें तो according to me there have been certain topics which have been frequent in the papers which you should not miss. Okay, and therefore today I bring you a very important topic, that is convex and concave functions. ये लगभग 4 बार लगातार आईआईटी के एग्जाम में आ चुका है. Okay, and क्यों ना आए? Because convex and concave functions are very important concepts in economics also as far as your utility functions are concerned. So let us try to understand what are convex and concave functions through these past year questions and see what all you need to know to crack these questions. So you don't need to know very hi-fi and technical things to prove or solve these questions. You just need common sense. So let us observe how are we going to do these questions. Okay, so the idea is that कि बहुत ज्यादा नहीं पढ़ना है, सिलेक्टिव पढ़ना है, स्मार्ट पढ़ना है, वो ज्यादा इंपॉर्टेंट है. ठीक है, सो लेट अस स्टार्ट. ये हम क्वेश्चन नंबर 2 देखेंगे which is from IIT JAM 2023. Yes. Okay, so we have been given two functions and the options are about convexity and concavity. So the first thing is that कि हमको ये पता होना चाहिए convex function क्या होता है और concave function क्या होता है. तो मैं आपको convex और concave function की बहुत बेसिक डेफिनेशन समझाऊंगी. ठीक है, so what is a convex function? The most important part. A convex function is a function such that when I draw the graph of the function, okay, and I take any 2 points on its domain. So suppose I take a point x and I take another point y, and then when I look at the images, okay, so the line joining those 2 points on the graph is either on the graph or above the graph. So basically line on curve or above curve. That is the definition of a convex function algebraically. Okay, तो अगर आप ग्राफ से समझना चाहते हैं तो आपके ग्राफ के ऊपर कोई भी 2 पॉइंट है, उनको ज्वाइन करती हुई जो लाइन है वो ग्राफ के ऊपर होनी चाहिए या एग्जैक्टली ग्राफ से कोइंसाइड करनी चाहिए. जैसे कि सपोज आई टेक दिस a line. Okay, so suppose this is my function a line. So if I take any 2 points on this line, the line joining will always lie on this line. So therefore this line is is representing a convex function. So that is the definition of convex function. ठीक है, similarly we have a definition of concave function. So what is a concave function? Exactly ulta. That means if I join any 2 points on the graph of that function, on the curve, that line has to lie below the graph or on the graph. Okay, so this is concave function and this is convex function. This is the first thing you need to know. So if by any chance you are able to draw the graph of the function and see what is happening, you will be able to make out whether a function is convex or concave. Okay, now let us try to attempt this question. Let f and g are defined by these two. So you can see that my f is a function. So it is representing a linear function when x is less than or equal to 1. It is again representing a linear function when x is greater than 1. ठीक है, so x less than 1 पे this is my 1. Okay, so at x equals to 1 my functional value will be 3 because x equals to 1 is here, so 1 plus 2 is 3, so my value will be here, so this is my point. Okay, and at x equals to 0 my value will be 2, so my line will be like this. So if you look at this, y equals to x plus 2, the slope of this line is 1. The slope is 1. Okay, now if you look at this line 2x plus 1, so y equals to 2x plus 1. So obviously this is not defined at x equals to 1, but if you see when I put x equals to 1 over here, I will get 3 again. So therefore there is no need to break away from this point. Okay, now let's put x equals to 2. So if you put x equals to 2, you will get y equals to 5. So I'll have a 0.5 somewhere over here and my curve will be like this. Now why my curve will be like this? Because the slope of this line is 2. So the slope of this line is 1, the slope of this line is 2. So the slope is increasing, therefore I get a curve like this. Okay, so now note that if you join any 2 points on the graph, any 2 point on the graph, the line will always be above the graph or on the graph. You can see that it will never go below the graph. So therefore f is a convex function. We have graphically established this fact. Okay, so wherever f is concave, we have to get rid of those options. Now let us check about g. So again look at g. Okay, this is x equals to 2. So when you put x equals to 0, so it is 0, at 2 it is 4, so somewhere over here. So my graph is like this. You look at the slope of this, the slope is 2, and you look at the slope of this function g, the slope is 1. Okay, so now the slope is 1, so my curve will have a slope like this. Okay, so my curve will bend like this, and therefore if I join any 2 points on this graph, the line will be below the graph and therefore g will be a concave function. So f is convex and g is concave. This is one way of looking at this problem. Okay, now my option number A is correct. Now another way of looking at the problem. Okay, so what is the calculus definition of a convex function? Calculus definition says a function is said to be convex if the second derivative of f is greater than or equal to 0. Okay, now what is the second derivative of f? Second derivative of f means d by dx of first derivative is greater than or equal to 0. What does it mean? It means that f dash x is an increasing function of x. Okay, so it means as x increases, f dash x also increases or remains constant. That is what it is trying to say. All right, now look at my function f. When x is less than or equal to 1, f dash x is 1. When x is greater than 1, f dash x is 2. So you note that as x is increasing, my slope is either remaining constant or it is increasing from 1 to 2. And therefore, f has to be a convex function. So this is another shortcut to look at the question without drawing the graph and conclude that f is a convex function. Okay, now similarly, the calculus definition of concave function. So what is a concave function? A concave function is the one whose second derivative is less than or equal to 0. That means d by dx of f dash x is less than or equal to 0. That means f dash x is a decreasing function of x. That means as x increases, f dash x decreases or remains same. So therefore, if you look at x less than or equal to 2, g dash x is 2. If you look at x greater than 2, g dash x is 1. So the derivative's value is decreasing as x is increasing. Therefore, g is a concave function. Same question, different way of looking at it. Whichever way you like, you can attempt questions. So convex and concave functions are not very difficult. You just have to remember the geometry and the definition, and you will be able to crack it. Now, to solve more such kind of problems, we have curated a special course for preparing for IIT JAM and GATE. Please join us and have a demo class with us, and you'll definitely like it. Okay, let's go to the next question. So you can see that to attempt this question, we just needed the definition and we could do it. Now let's go for the second one. IIT JAM 2020. So this, I would say, is a very easy question. So you are very lucky if you get a question like this. So you see what they ask. So let fx is equal to e power x and gx is equal to log x. So domain is given. The domain of the exponential function is the set of all positive real numbers. The domain of logarithmic function is set of all positive numbers. Again, exponential functions and logarithmic functions are really important for economic students because they're related to exponential growth and decay models. All right. So we have to again check convexity and concavity. Okay, so see, I can easily calculate the derivative. So I really don't need to make the graph as also. So f dash x is e power x. F double dash x is e power x. Okay, now e is approximately 2.7 and e is greater than 1, we can see. So as x, whatever x you take, e power x will always be positive. Why? Because any positive number to any power will always be positive. The power of a positive number can never be negative and it can never be 0. So this is a strict convex function. It does not even become equal to 0. So f is a convex function. Okay, so that we know. Now look at g. So again, g is differentiable. G dash x is 1 upon x. Then if you calculate the second derivative of 1 upon x, log x, it will be minus 1 upon x square. Now, as x is positive, x square is never equal to 0. So therefore, the second derivative is defined. That is really important to know. And g double dash x is negative because of this negative sign, and x square is always positive. So therefore, g will be a concave function. So d, f is convex and g is convex. Now, in this question, you could do it simply by calculating the second derivative. Of course, in this question, you cannot, check whether f dash x is decreasing with time or increasing with time because I am not given a piecewise function. So either I have to know the graph, but there is no need to know the graph. You could just do it by simply calculating the second derivative. All right. So you can see that convex and concave functions are occurring. They're coming again and again, and they are not very difficult also. Okay. So to know such concepts which are constantly coming in the examination, which are very important, please subscribe to our channel. Please come and try us at EduSure, and I'm sure you'll benefit from it. All right, let's go to the next question. So, by the third question, you will feel very nice that, by the end of it, you'll be able to attempt these questions. Okay, so this is IIT JAM 2021. 21, question number 21. So year 21 and question number 21. So again, I'm given fx and gx. So again, convex, not convex, quasi-convex and quasi-convex. So I have one more term, quasi-convex. Okay, so let me just introduce the concept of quasi-convexity and quasi-concavity. Okay, so a function is said to be quasi-convex if, f of lambda x plus 1 minus lambda y is less than or equal to maximum of fx comma fy. Okay, basically this is a algebraic definition, so do not get overwhelmed by it. It means, what it means is this: if this is my point x, this is my point y. Okay, so obviously here lambda belongs to the closed interval 0 1. Okay, so obviously my any point between x and y is lambda x plus 1 minus lambda y. That you should know. Okay, so what it is trying to say is that now this is my fx and suppose this is my fy. Okay, fy. So this is fx and fy. Now my graph should be like this, that at any point between these two lines, these 2 points, whatever my functional value has to be less than or equal to the maximum of these two values. That means, suppose if my graph is like this, suppose my graph goes like this, then you can see that at this particular point, or let me make it larger like this. So at this particular point, this value is greater than maximum value. So this will not be quasi-convex. Okay, so quasi-convex means whenever I have a graph and I join, 2 points on the graph, so my functional values has to be less than or equal to the maximum of both the end values. That is what I mean by quasi-convex function. And similarly for quasi-concave, the value on the graph should be greater than or equal to minimum of fx and fy. Okay, so any increasing function, any monotonically increasing function is always quasi-convex. Okay, now we will use this. So if a function is constantly increasing or constantly decreasing, it is a quasi-convex function. Now let's come to this question. So let us come to f first. So f of x is x e power minus x. So f dash x is x e power minus x into minus 1. We are using product rule. Okay, so f dash x is e power minus x and 1 minus x. So let us calculate the second derivative. E power minus x minus 1 plus 1 minus x minus e power minus x. So the second derivative is x minus 2 e power minus x. Okay, so let us look at this second derivative. Now notice that if x is greater than 2, my second derivative will be positive, and if x is less than 2, my second derivative will be negative. Therefore, on the domain of this particular function, my convexity and concavity will not be uniform. On some part of the graph is going to be like this. On some part, the graph is going to be like this. So if my graph is not following the same pattern throughout its domain, it is neither convex nor concave. So therefore, this particular function fx is neither concave nor convex. So f and g are both convex. This is gone. F convex, g not convex. This is also gone. Okay, so a and b are gone. Okay, now we have to check the quasi-convexity. Okay, so let's go to G now, because in both these options we have, in both these options it is given that F is not quasi-convex. Okay, and here it is given neither F nor G is quasi-convex. So the only thing that is differentiating both these options is the quasi-convexity of G. Okay, so I think we should now check G, minimum possible efforts. That is what is needed to solve this question. So Gx is x mod x. So Gx is equal to x square if x is positive, because if x is positive, mod x is x. Gx is equal to minus x square if x is negative, and it is 0 if x is equal to 0. So my graph will be like this: x negative, x equals to 0, x positive. Now look at this beautiful graph. It is neither convex nor concave. You can see that over here the curve is above the line, over here the curve is below the line. So neither convex nor concave, but you can see that as x is increasing, my graph is increasing. So it is an increasing function, and therefore it is quasi-convex. So the correct option is F is not quasi-convex and G is quasi-convex. In this question, please do not end up wasting your time on checking the quasi-convexity of the function F, because it is not important. Okay, so what is the idea behind solving the question? The idea behind solving the question is not to take the question on your ego. Do the bare minimum to get to your final answer. So I think with the end of these 3 questions, it should be really clear to you that how convex and concave functions are very important for IIT JAM or ISI preparation, and also how to tackle these problems. So you should know the algebraic definition, geometric interpretation, and the calculus approach to go and solve convex and concave function. I hope you like this video, and if you do, please comment in the chat, and you can tell us other videos you would like to watch from our side. Please subscribe to our channel and join Ellie Shore. Thank you very much. See you in the next video.